So, what is coding? So, this video is aimed to help everyone learn coding no matter what your background is. It's not really necessary to be an engineer to learn coding. So, what is coding? Basically, when mathematics was evolving, we needed machines to compute that for us. That is where computer was born. A system only understands 1 and 0, and we call this binary. See, you need to know all this before you start gagging up lines, because it's not all about that. You need to learn the theory before you learn coding. And it's not like hundreds of pages of theory, it's basically just like 15 minutes. So, computer only understands binary. This is the thing that directly goes inside our CPU and we get a desired output. You can see that everything is evolving by this day. The machine language also evolved. The first generation of language is known as machine level language, and so on. We have 5 generations of languages coming up on the board, right? So, the first generation of languages was machine level language. This is the lowest level and talks directly to the hardware. As I said, everything goes inside the CPU. In our case, it is binary 1 and 0. This is the only thing that goes inside the CPU, no matter what you're doing, whatever you're coding and everything. It has fast execution. It is the fastest in execution. It is impossible for humans to read, obviously, because it's a pile of 1 0 1 0 1 0 1 0 1 1 1 0 1 0. So it's basically not possible for humans to understand this. Then there comes the second generation of languages, which is assembly level language. What's happening here is that it uses mnemonics instead of binary. So here, let me give you an example. Instead of writing 1 0 1 0, we write move a comma 5. This is an assembly level code. We'll move into it after a while, but for now you need to know that it is using mnemonics. Then each instruction maps one to one with machine code. So basically the instruction that you are giving is mapped directly to machine code. It is directly converted to binary code. It is not that uh, close to hardware, but it gets converted. Then it's easier than machine code, obviously, because we are not writing a bunch of 1 0 1 0 and everything. Then this is the most important point. It needs an assembler to convert to machine code. What's an assembler? Basically, since the first generation of languages was directly connecting to the CPU, all the other generations need a translator. This is the term that we use. They need a translator. In case of assembly level language, the translator is assembler. Moving on, we'll find out that in case of the third generation of languages, there are interpreters and compilers. I'll talk about this very soon. So, where is this used? It is used in embedded systems, firmwares, and device drivers. Embedded systems is something that is related to electronics. So, these are the little systems that, like in your washing machine, there is an embedded system that is telling it you need to turn 3000 times. This is your RPM, this is the time. That is where this is used. Coffee break. So now we move on to third generation of languages, which is high level language. This is where all the boom comes in, like Python, C, C++, Java, JavaScript and everything. These are all considered as high level languages. It has English like syntax. Programmer doesn't need to worry about register or memory. Now what are these? A video will be coming up upon these. These are basically parts of CPU. Register is a very fast memory, and memory is basically your storage. Whatever we write is stored somewhere. Programmer doesn't need to worry about that while using high level languages. And obviously it is slightly slower than low level language, because here it goes through the translator. As we talked about the translator, it is going through the translator. In case of high level languages, the translators are either compiler or interpreter. There are others too, but these are basically what you need to know right now. Compiler basically compiles the whole code at once. If this is your block of code, it will be compiled at once. In case of interpreter, whatever you are writing is compiled at the same time. This is what happens with Python. Example, if you're writing a is equal to 5 and you press enter, this will trigger the interpreter and it will be stored in the memory that a is equal to 5. So this is the most important level of language because this is where we are working. And the reason why it is slower is that this is going to the translator and everything. But in case of the lower level languages like first generation or second generation, these were directly connected to the CPU. First generation is obviously directly connected to the hardware. Second generation goes to the first generation and it gets connected to the hardware. Then there comes the fourth generation and fifth generation of programming languages. The fourth generation is called as non-procedural language. It is basically used in databases. It has less of work and more of automation. This is used in SQL, MATLAB, Matrix Laboratory. This is where it is used. Then there is the fifth generation of language, which is logic based language. It is mostly used in AI and stuff. This is basically all about logic. We won't dive deeper into all this right now. Obviously, we will be studying SQL, but yeah, this is not something that you need to focus on right now. Your focus should be on high level language. Now we'll dive deep into it and we'll see what this is all about. Now you know the theory behind it, and now we'll dive deeper into high level languages. So, high level language: C, C++, Python, Java, JavaScript, all of these are high level languages. They have English like syntax. And they need a translator. In case of C, there is a compiler. In case of Python, there is an interpreter. They are different. Compiler compiles the whole code at once, whereas interpreter compiles line by line. This is the main difference between them. So what's happening here? What's happening? Like, why am I saying that this is all about mathematics? Everything that we do with the computer eventually comes down to an addition state. Everything comes down to an addition state. That's the thing. That is why mathematics is important here. For example, if you're building a server, if you're building a database, if you're building something for a bank, like which checks the withdrawal, debit, and everything, it is all about mathematics. And that is where high level languages help us to build such things. So let me get a little more, let me make you a little more intuitive about all this. So in case of C and Python, we write two different things. This is where initialization is important. Like, you are going to learn coding now, so I'm telling you this beforehand so that it can be easier for you. To me, it took around an year to learn what coding is actually. I wasn't able to understand why there is only a in Python and int a in C. What's happening? So there are different levels, there are different things. Some languages need initialization, whereas some don't. They just work with it. That's how you can literally talk about it right now. So in case of C, if you want to have a variable a and you want to assign it a value 5, this is a decimal value. you need to add int before it. This is where the initialization part comes in. Whereas in case of Python, you can directly write a is equal to 5. In JavaScript, you can directly write a is equal to 5, or you can add a const here. That's how it works. In case of C, if you want to write a float number, float is basically decimal number. This is a standard number, but in computers we call this decimal number, and like 5.5 is called as a float number. So here you have to add float a is equal to 5, whereas in case of Python you can directly write a is equal to 5.5. So it is not that tough, but you just need to know which language works in which way. C needs initialization, Python doesn't, JavaScript doesn't. Java needs initialization, JavaScript doesn't. So this is where everything is different. And this is where you start twisting the words to make something useful for yourself. This is where you start writing stuff that can be executed well, that can be written well, that will be useful. It's all about mathematics. For example, as I talked about the bank server, if you want to create a machine, a program that calculates the withdrawal, debit, and credit, it's very simple. It might be looking a little tough, but it's very simple. For withdrawal, what we are doing is basically subtraction. For debit, it is subtraction. In case of credit, it's addition. Where is it getting these things done? Like, what are we subtracting from? What are we adding to? We are adding to memory. What is the memory? Memory is basically a bank account. This is memory. This is how it works. This is a part of the memory. This is your code, and it uses the memory to give a desired output. That's it. This is coding. This is coding. Now I can give you an example. I'll just add the program in my GitHub right now, and you can see that this is how it works. That's it. This is the mathematics that you need. So now for recap of this, the first generation of language was machine level. This uses binary. The second generation of language is assembly level language. It uses mnemonics and needs a translator. Translator is what? It is basically converting our code to binary level so that the CPU can read it. Then there is the high level language. This is what we work with. It has English like syntax, and it is slower than these two because it goes through the translator as well. Then there is non-procedural language, which is used in SQL and other types of databases. So this is a very important topic. There are different paradigms of programming. What do I mean by paradigm? There are different structures. There are different ways to program. So first is procedural, and then there is object oriented. This is very important because you are going to learn it, and you need to learn it, and it's very tough for some people, but it can be made easier. So first we'll talk about procedural programming. In procedural paradigm, the program is divided into functions. What are functions? Functions are basically a set of rules, a set of program to attain a goal. Okay, so this is basically written to attain a goal. Like we can make a function, calculate sum. This can be a function. It will take two variables, a and b, and it will give us the sum a plus b in C. We define a variable for that. We'll talk about this as we move further. It is step-by-step execution. What does this mean? That execution is done step by step. The first line, the second line, the third line, it will go top to bottom. That's how it's done. Now, what are the control structures in it? What do I mean by control structures? Control structures are basically the sequence in which it gets from top to bottom. There can be normal sequential. This is normal. Then there is selection, if, else. What does this mean? If and else. If you are eating fish, you can't drink milk. Else you can drink milk. That's how it works. This was a very basic example, but that's how I'm going to tell you about it. If else is basically telling us to select between two options, A and B. If you satisfy a condition, you can go to A, else you have to go to B. This is how the selection works. Then there is iteration. What is iteration? It is basically looping around something. Iteration is basically looping around something. There are three basic types: for, while, and do while. These are basically the basic types. There can be for in and other things like for in, etc. And the places where it is used is it is used in basic language. Basic is actually a language. Then there is C, C++, Fortran, formula transformation. So this is where we use procedural programming, going top to bottom. Then there comes object oriented programming. It organizes the program around objects. What are objects? Objects are basically some sort of thing that follows a blueprint. Class is the blueprint. It tells you, okay, I have a class man, I have a class woman. They have different chromosomes, they have different abilities, they have different work. So this is how it works. So class is basically a blueprint, an object is an instance of a class. If this is a class, then we can make different objects with it. We'll learn more about it in upcoming videos. The places where it is used is C++, Java, Python. All of these are object-oriented programming based. So this is secure because here you can secure your variables, whereas here there is no security. These are global variables. We'll talk about it. What is global, what is not. Then there is code reusability. The code that you write in object-oriented paradigm can be reused, but here you can't reuse it. Like you can, but you can't. So now let's go to some coding examples. Okay, so let's dive deeper into the concept and talk about tokens. So what tokens are? Tokens are basically the smallest meaningful units inside a program that a compiler or an interpreter understands. You can find this in every other programming language. It is not limited to just C, Python, Java or anything. These are there in every other language. There might be different words used inside the theory, but you can call it tokens. Like in one of the languages, we call it atoms or lexes. There are many words, but let's focus on the widely used terminology. So that is tokens. There are 6 basic types of tokens. As you can see on the board, we have keywords, identifiers, constants, operators, separators, and special symbols. We'll talk about this as we dive into the concept. So what are keywords? Keywords are basically some of the reserved words with predefined meaning. For example, if we want to define a function, this might be a little tricky for you because you're learning right now, but that's how I'm going to show you. So if we are defining a function, calculate sum. So here, def, define, this is a keyword. This is predefined. You cannot use this as your variable. Now let's talk about variable. If we write a equal to 5, now you can learn two terms over here. A is a variable. This is defined by the programmer. As you can see, the second one over here, that is identifier. A is an identifier and 5 is a constant. As you can see here, this is a constant. This won't change value. You can even define a constant by yourself. You can write const a. This is a C program. Const a is equal to, or you can just write 5. Now this will define it as a 5. Then there are operators. What do you mean by operators? Operators are basically uh, symbols used to perform operations. As you can see on the board, symbol used to perform operations. For example, if we have like if we add over here b is equal to 10 and then we add c is equal to a plus b. So as you can see over here, we are using the plus symbol. What does this plus symbol mean? This is an operator. We can write minus a. Minus is also an operator. Now you know that. Now let's talk about separators. For example, if I want to do c is equal to a plus b and their average divide by 2. According to BODMAS, this will flicker a little, but if I do this, it won't flicker a bit. You will get what you want. You will get the average. How is this happening? By the parentheses. Parentheses are separators. These are punctuators used to separate parts of program. Now we'll talk about special symbols. So special symbols are something that you will learn about, like that will be more in use in C or other programming languages, even in Python also. But for now, we are using Python, so I won't be able to help you out because this will be a little tricky. Of course, I'll be able to help you out, but this will be a little tricky. So let's talk about it. So what are special symbols? These are the symbols that are used to control program structure. Okay, like in C language, let's just talk about C. If we write hashtag include stdio.h, now this will include the standard IO library. That's what's the use of a special symbol. This is a special symbol. Hashtag is a special symbol. Then there comes and, there comes multiply. Of course, that is used in other languages too. The star symbol is not just for multiply, it is used for other things too. Like in SQL, we use it to select all the data inputs, and that's how it's used. So now hopefully we are clear about this, but we'll get to learn more about it as we move further. Okay, so moving further, let's generate our first Python program. I can use the thing print hello world, and this will print a hello world for us. So as we discussed about it, print is a keyword over here. It's a defined word. You cannot use this as a variable. You can't write print is equal to 5. This will be wrong. You can't do that. So that's how we wrote our first ever program, that is hello world. So what it does is, this is an interpreted language. Here we are using VS Code, but if you're using the Python IDE, as soon as you write print hello world and then press enter, you won't get another line. This will just print hello world for you, like over here. Okay, so now let's define some variables. If we write a equal to 5, this will define ourselves a 5, and if we write print a, then we can get a 5 as a variable. So this is a defined variable. This is a special symbol. Equal to is a special symbol. Okay, so and then we talk about control structures that was using if, else, etc. So that we'll use in upcoming further lectures. For now, my goal was to tell you all what programming is. We learned about the generations of languages. We learned about the control structures. We learned about everything. We learned about the paradigms. Now we have also discussed tokens. So I'll meet you further with a playlist on C and Python. For the meantime, I wish you all a very good health. See you.